In this lesson, we're going to introduce some notation that is going to be pretty important a little bit later in your calculus career. So this is the idea of a limit. I want to start by considering this piecewise function here, and then I'm going to explain exactly what a limit is. So as we look at this function, you've seen this now in previous lessons. We know that we have this point that is not on the line that the rest of the function is defined as, right? So this point, remember, is called a removable discontinuity. And we would say, based on this point, this point is 1, 2. We'd say f of 1 is equal to 2, right? And that's just reading the point off the graph. What we want is a way now to talk about the fact that this function looks like it approaches this point where it has the hole, even though it's defined in such a way that at that point, the value of the function is far from the line. Okay. In other words, like we wanted to talk about the value that the function approaches as x gets close to 1. Okay, so that's the definition of a limit. So even though f of 1 equals 2 for this function, we now have a way to say that the rest of the function approaches this point 4 as x gets close to 1. The way we would say that is the limit as x approaches 1, so that's this point right here, of f of x, and f of x is our whole function, right, is equal to 4. Okay? So my first statement, f of 1 equals 2, says that the value of the function is 2 when x is equal to 1. My second statement says this. So the limit as x approaches 1 of f of x equals 4 means that the function gets close to 4 as x gets close to 1, right? So in other words, as I'm walking along this curve from either direction, right, I'm walking towards this point y equals 4, right? Even though if I'm standing on the function at x equals 1, I'm standing at this point. Okay? The reason this is useful to us is because now we can talk about a function that might approach a different value from two different directions. So let me show you what I mean by that. So this is a graph from your Delta Math problems, and what Delta Math asks you to find is the limit as x goes to 3, negative 3, and then it might have like a little negative, and it might also ask you to find the same limit as x approaches negative 3 on the positive side. Okay? So take a look at this point here. Think about what this might mean. So we're looking at this little jump discontinuity now. Okay. So what the difference between these two things is, and the reason this is useful notation to us, is because this limit is the left limit and this limit is the right limit. So in other words, these two statements both say we're walking to this point x equals negative 3 on this graph of f, but we're walking from the opposite direction. And this is interesting because we end up in different places. So let me use two different colors for this. So the left limit, I'll do in green, means I start from the left of negative 3, which is over here, and I'm walking towards x equals negative 3, and I would end up at this point here. Okay? So the y value at this point is 6. So I'd say that's left limit is 6. Okay? Now, let's say I'm looking at the right limit, approaching from the positive direction. That means I'm walking along the function towards that same point, still x equals negative 3, but on this other piece of the graph. And notice I end up at a different spot now. So this is, the y value here is 5. This limit is 5. Okay. So these little plus or minus, these tell you which direction we're approaching from. Okay. So we're no longer reading just the value off the graph. We're looking at the value that the graph approaches. And it no longer matters if we have an open or a closed circle. We're just looking at the value that we're getting close to as x approaches this certain number we're given. We'll do one more example so you can see another one. So here's another piecewise function with a discontinuity. And here is our limit statement. So we're looking at, because there's a little negative here, we're looking at the left limit. Or we would say we're approaching from the negative side. Okay? So what that means is I'm going to start from the left of my point, x equals 1, which is here, right? I'm going to walk along this curve, and I'm going to see at what point I would end up. And that point would be 0, obviously y equals 0. So I'd say the limit as x approaches 1 from the negative side of f of x is equal to 0. So that's it. Now, they obviously did not ask us for this, but if they ask me the limit as x approaches 1 from the positive side of f of x, well, that means I'm going from the right-hand side towards x equals 1, and my y values approach -4. Okay? So that's my right limit. So again, this allows us to distinguish which piece of the graph we're talking about and which direction we want to talk about the x value that we're approaching. That's all we're going to do with this notation for this year, but again, you're going to see a lot of this next year.